inverse of tan 4. So we can apply the formula tan inverse of tan x, which is equal to x. So my answer is 4. So this belongs to real numbers or not? X belongs to R. So if it is not belongs to its domain, then we have to convert into its particular domain. Then we should simplify. Next, one more. Tan inverse of 1 plus x by 1 minus x equal to pi by 4 plus tan inverse x. Prove that tan inverse of 1 minus x by 1 plus x 1 plus x by 1 minus x 1 plus x by 1 minus x equal to pi by 4 plus tan inverse of x where x less than 1. See, they have given this particular question. LHS, take LHS, tan inverse of 1 plus x by 1 minus x. Tan inverse of 1 plus x by 1 minus x. Tan inverse 1 plus x by 1 minus x, take as LHS. So 1 can be written as. So how I can write this one? A plus b by 1 minus ab. See, tan inverse of 1 plus x by 1 minus 1 into x. So we have a formula, tan inverse of x plus y by 1 minus xy is equal to tan inverse of x plus tan inverse of y, where xy less than or equal to 1. So here these are variables. At the time we cannot see where x is less than 1, x into 1 is also less than 1, right? So we can apply this formula. Equal to will not come. Now, so if I apply that formula, what I get? So this can be written as tan inverse of x. What is x? 1 plus tan inverse of y. What is y here? X. So tan inverse of 1 is pi by 4 plus tan inverse of x. Next problem. Find domain, range of sin inverse x plus cos inverse x plus tan inverse x. So entire thing you consider it as y. Domain. So domain, how we will find? If we have a combination of P or more than two or more than two functions, what we have to do? We have to find a particular domain. Next we should take its intersection part. So what is the domain of sin inverse x? Minus 1 to 1. What is the domain of cos inverse x? Minus 1 to 1. What is the domain of tan inverse x? Real numbers. So what is the intersection of this all? Which is nothing but minus 1 to 1. So domain of the given function is minus 1 to 1. So now I am going to find range of the function. If I want to find range of the function, entire thing we have to express purely in terms of sine or cos or tan. So how I can express? You see, I have a formula. Sin inverse x plus sin inverse y is sin inverse x plus cos inverse x is equal to pi by 2. So this can be replaced as pi by 2 plus what I have, tan inverse x. See, we have a function of purely in terms of tan. So what is its range? Actually minus pi by 2 to pi by 2. What is its range? Minus pi by 2 to pi by 2. What are open? But its range depends on domain. Range depends on domain. If the domain is all real numbers, we will get minus pi by 2 to pi by 2. But you see, the domain is minus 1 to 1. The domain of the given function is minus 1 to 1. So accordingly we have to take its range. So if tan inverse x is minus 1, what is our range? What is our range? Minus pi by 4. Tan inverse of minus pi by 4, which is nothing but minus 1. So if x is 1, what is tan inverse 1? Pi by 4. So we can split it into two parts. Pi by 2 minus pi by 4. The range is nothing but pi by 2 minus pi by 4, comma pi by 2 plus pi by 4. Pi by 2 minus pi by 4, which is nothing but pi by 4. Pi by 2 plus pi by 4, which is nothing but 3 pi by 4. This is the range of given function. So whatever the function they have given, see if it contains two or more than two different inverse trigonometric functions, we have to find its domain. Later we have to take its inverse. Its intersection. While finding range depends on its particular domain. So with respect to domain, we have to consider particular ranges. Then we should simplify. The next problem. Next, prove that tan inverse 1 by root 3 tan x by 2 is equal to 1 by 2 cos inverse 1 plus 2 cos x by 2 plus cos x. 1 plus 2 cos x by 2 plus cos x. Okay, we solve this problem. So we have to relate a tan inverse in terms of half cos inverse. Tan inverse and cos inverse we have to relate, and these are not directly related. Tan inverse is related half of cos. Just recall the properties. So we can write cos inverse 1 minus x square by 1 plus x square as 2 tan inverse x. So tan inverse x is equal to 1 by 2 cos inverse 1 minus x square by 1 plus x square. Now in place of x, what we have? We have 1 by root 3 tan x by 2. Okay, we solve this LHS. So according to formula, what I can write? Half cos inverse 1 minus 1 by root 3 tan x by 2 whole square by 1 plus 1 by root 3 tan x by 2 whole square equal to 1 by 2 cos inverse 1 minus tan square x by 2. Don't take square of this. Tan theta whole square is tan square theta by root 3 whole square is 3 whole divided by 1 plus tan square x by 2 by 3. If I simplify this, 1 by 2 cos inverse of 3 minus tan square x by 2 by 3 plus tan square x by 2. But my answer is in the form of 1 by 2 cos inverse 1 plus 2 cos x. So this tan square x by 2 I have to convert in terms of cos x. Tan square x by 2 I have to convert in terms of cos x. So what we have? A cos 2x formula and cos x formula. What do we have? Cos x and cos 2x. Cos x can be written as 1 minus tan square x by 2 by 1 plus tan square x by 2. 1 minus tan square x by 2 by 1 plus tan square x by 2. Now I have to replace tan square x. So I'm not finding anything. So I simplify like in terms of cos and sine. So I write it as 1 by 2 cos inverse of 3 minus sine square x by 2 by cos square x by 2 whole 3 plus sine square x by 2 by cos square x by 2. Now again 1 by 2 cos inverse. If I take cos square x by 2 common, what I get? 3 cos square x by 2. So if I take divided by cos square x by 2, here also we have cos square x by 2. Both will be gets cancelled. 3 cos square x by 2 minus sine square x by 2 by 3 cos square x by 2 plus sine square x by 2. Still I have to simplify. 1 by 2 cos inverse. 1 by 2 cos inverse. So 3 cos square x by 2 minus sine square x by 2. 3 cos square x by 2 minus sine square x by 2. How I can simplify? See, I have to eliminate this sine square x by 2. I can write this sine square x by 2 as 1 minus cos square x by 2. So I can substitute 3 cos square x by 2 minus 1 minus cos square x by 2 will become minus of 1 plus 1 plus 1. See, minus 1 minus cos square x by 2. So I can write it as minus 1 plus cos square x by 2 by 3 cos square x by 2 plus 1 minus cos square x by 2. 1 minus cos square x by 2. Now 3 cos square x by 2 minus cos square x by 2. 1 by 2 cos inverse 3 cos square x by 2 plus cos square x by 2 is 4 cos square x by 2 minus 1 by 3 cos square x by 2 minus cos square x by 2, which is nothing but 2 cos square x by 2 plus 1. So I go to the cos square x and cos x relation. Cos square x. So shall I go to its multiple angle? Cos 2x is equal to 2 cos square x minus 1. So 2 cos square x can be written as 1 plus cos 2x. So I don't want in terms of x, I want its submultiple. So I can write 1 plus cos x is equal to 2 cos square x by 2. So if I want 4 cos square x by 2, what is 4 cos square x by 2? Multiply by 2, 2 plus 2 cos x. Substitute those 1 by 2 cos inverse of 4 cos square x by 2 is 2 plus 2 cos x minus 1 by 1 plus cos x plus 1. So we get the answer as 1 by 2 cos inverse 2 cos x plus 1, nothing but 1 plus 2 cos x by 2 plus cos x. 1. Okay. So I have tan inverse of something. If I get tan inverse of tan theta form, I can write it as theta. Means tan inverse of tan x, which is equal to x. So we should be able to convert this particular thing in the form of tan. So for that purpose, what I am doing, dividing everything by cos x. If I divide everything by cos x, what I get? Tan inverse of cos x by cos x minus sin x by cos x by cos x by cos x plus sin x by cos x. Cos x by cos x 1. So what I am getting? Tan inverse of 1 minus tan x by 1 plus tan x. So this 1 can be rewritten as tan inverse of tan pi by 4 minus tan x by tan pi by 4. Otherwise we write it as 1 plus. So we don't have anything, we can write it as 1. So 1 into tan x is tan x. That 1 can be replaced as tan pi by 4, because I want to convert into formula. Tan a minus tan b I have here 1 plus I got tan b. I got tan, which is nothing but tan x. If suppose I am able to get tan a, I can convert it into formula. To get it, I am writing it multiplied by 1. So that 1 can be replaced as tan pi by 4 into tan x. So it is in the form tan a minus b. So I can rewrite it as tan inverse of tan a minus b. So we know the formula, tan inverse of tan x is equal to x, which is nothing but pi by 4 minus x. The answer is pi by 4 minus x. Next question. Find the value of tan inverse 1 by 2. Find the value of tan 1 by 2. Find the value of, next question, tan 1 by 2 into sine inverse of 2x by 1 plus x square plus cos inverse of 1 minus y square by 1 plus y square, but xy is less than 1. Xy is less than 1. So what I can do here, see, I can write this one as tan 1 by 2 of sine inverse of 2x by 1 plus x square can be written as 2 tan inverse of x according to formula, right? Multiple angles, the last one what we have discussed, plus cos inverse of 1 minus x square by 1 plus x square is 2 tan inverse x, but in place of x we have y, so we can write it as 2 tan inverse y. Take 2 common, so what I am getting, tan 1 by 2 into 2 into tan inverse x plus tan inverse y. Tan inverse x plus tan inverse y. So tan inverse x plus tan inverse y, what I can write here? Tan inverse x plus tan inverse y can be written as tan inverse of x plus y by 1 minus xy, but xy is less than 1. If xy is greater than 1, we have to write pi plus. What we have to write? Pi plus. Okay. Now what is my answer? Tan of tan inverse x is equal to x. So my answer is x plus y by 1 minus. Prove that 2 tan inverse 1 by 3 plus tan inverse 1 by 7 equal to pi by 4. This we need to prove. So when we can apply tan inverse x plus tan inverse y formula? If I have here tan inverse x alone, but what I have 2 tan inverse x, this can be done in 2 ways. We can split this 2 tan inverse x like tan inverse x plus tan inverse x. We can apply twice the formula, or we can write this 2 tan inverse x. We can write this 2 tan inverse x as formula beyond 2 tan inverse x is equal to tan inverse of 2x by 1 minus x square. So we can use this formula to simplify the given one. So if I use this, what I get? Tan inverse of 2 into x 1 by 3, so 2 by 3 by 1 minus x square, what I get? 1 by 9 plus tan inverse 1 by 7, which is LHS. Next step, simplify this, what I get? Tan inverse 2 by 3 by 9 minus 1, 8 by 9, 3 1s are 3 3s are 2 1s are 2 4s are, plus tan inverse 1 by 7. Next, so what I get? Tan inverse 1 by 4 by 3, nothing but 3 by 4 plus tan inverse 1 by 7. Now what I am getting? Tan inverse x plus tan inverse y formula, which is nothing but, see, I have to apply this thing, x into y, whether xy is less than 1 or xy is greater than 1. xy 3 by 4 into 1 by 7. 3 by 4 7s are 28, which is less than 1. So I have to apply the first one, which is nothing but tan inverse of x plus y by 1 minus x into y. So apply the formula. Tan inverse of x plus y 3 by 4 plus 1 by 7 by 1 minus 3 by 4 into 1 by 7, which is equal to tan inverse, take LCM, 7 3s are 21 plus 4 by 28 minus 3, 27 4s are 28, 28 is LCM, LCM 28, denominator, 7 4s are 28, 28 is LCM, so 28 LCM, then what I get? 28 minus 3, 28 minus 3, 25. So 28 cancel, 21 plus 4 25, 25 cancel, what I get? So I'll get tan inverse of 1. We know that tan inverse of 1 is pi by 4, which is RHS. Next, the next question. Cot inverse of 1, prove that cot inverse of 1 plus cot inverse of 2 plus cot inverse of 3 is equal to tan inverse of 1 plus tan inverse of 1 by 2 plus tan inverse of 1 by 3, which is equal to pi by 2. Which is equal to pi by 2. So this one we have to prove. Take the first one. What they have given? Cot inverse 1 plus cot inverse 2 plus cot inverse 3. So directly we don't have a formula like cot inverse x plus cot inverse y. So we learn in terms of tan. So try to convert the cot in terms of tan. So what formula we have? So we have cot inverse x as tan inverse of 1 by x for x greater than 0. Pi plus tan inverse 1 by x for x less than 0. 1, 2, 3. All the values are greater than 0. So we go to the first formula. Then we can write it as tan inverse of 1 by x value is 1 plus tan inverse of 1 by x value 2 plus tan inverse of 1 by 3. Now we have to simplify this. This what is this? Tan inverse of 1. Tan inverse of 1 is nothing but pi by 4 plus tan inverse of x plus tan inverse of y formula. Tan inverse x plus tan inverse y. Tan inverse of, check whether xy less than 1 or xy greater than 1. 1 by 2 into 1 by 3, which is equal to 1 by 6 less than 1. So we go to the first one, which is nothing but tan inverse of x plus y by 1 minus xy. So 1 plus 1 by 2 plus 1 by 3 by 1 minus 1 by 2 into 1 by 3. Next, pi by 4 plus tan inverse, take LCM, 6, 3 plus 2 by LCM 6, 6 minus 1, 6 minus 1, 6 and 6 gets cancelled, 3 plus 2 5, 6 minus 1 5, 5 and 5 gets cancelled, we get 1 time. So pi by 4 plus tan inverse of 1, so we can get it as pi by 4 plus pi by 4 is equal to pi by 2, which is RHS. Prove that cos inverse 3 by 5 plus sin inverse 12 by 13 equal to sin inverse 56 by 65. This is LHS and this is RHS. We have to prove. See, in LHS, we have one is in terms of cos, another one is in terms of sin, and result is in terms of sin. So we have to convert this cos in terms of sin. So I can convert cos in terms of sine. Cos inverse x is equal to sine inverse of root 1 minus x square. So this can be converted in this way. So I can rewrite this as sine inverse of root 1 minus x square 9 by 25. 9 by 25. So I get 25 minus 9, 16 by 25. Sine inverse of 16 by 25 under root. So what I'll get sine inverse of 4 by 5. So what I'm getting? Sine inverse of 4 by 5. Now this cos inverse 3 by 5 can be replaced as sine inverse of 4 by 5. So replace and start solving. So this can be rewritten as sine inverse of 4 by 5 plus sine inverse of 12 by 13, which is LHS. Now it is in the form sine inverse x plus sine inverse y can be written as sine inverse of x into root of 1 minus y square, x into root of 1 minus y square plus root of 1 minus x square into y. Okay, simplifying that way, which is equal to sine inverse of x 4 by 5 into root of 1 minus y square 12 square 144, 13 square 169 plus root of 1 minus x square 4 by 5 whole square 16 by 25 into y, which is nothing but 12 by 13. Now sine inverse 4 by 5 into root over 169 minus 144, which is nothing but 25 by 13 plus root over 25 minus 16, 25 minus 16, 9, 9 by 25 into 12 by 13. Now can be written as sine inverse of 4 by 5 into 5 by 13 plus 3 by 5 into 12 by 13. No need to cancel this. We have 5 into 13, 5 into 13. We can take it as LCM. So 5 13s are 65. So sine inverse in denominator we get 65. 4 5s are 20 plus 3 12s are 20 plus 3 12s are 36. 20 plus 36, 56. We get the answer as sine inverse of 56 by 65, which is RHS. Next, go to the next problem. The next problem given as sine inverse plus cos inverse equal to cot inverse. See, these are how interlinked. We can write a sine inverse in terms of cos. Then we can apply formula. We will get a cos total in terms of cos. After that, we can convert that cos in terms of cot. It's one procedure. All three we can convert in terms of tan. Then we can compare. So in these two methods, the second method is suitable, which is simple. So take LHS, convert sine and cos in terms of tan. So what is the formula? If we forget the formula, we can go with triangle method. Take sine inverse of 4 by 5 as x, then we get sine x equal to 4 by 5. Right angle triangle. So if I take this one as x, 4 and 5, automatically we get it as 3. I want to convert in terms of tan. So tan x is equal to tan x is equal to 4 by 3. X represents sine inverse 4 by 5 can be written as tan inverse 4 by 3. Tan inverse 4 by 3. Right? Go to the next. Cos inverse 2 by root 5. Take it as y. So what I get? Cos y is equal to 2 by root 5. Take triangle. Let it be y. 2 root 5. What about opposite? Is hypotenuse square, root 5 square is 5 minus side square 4, 5 minus 4, 1, root 1 is 1, I got here 1. Then what about tan y? So I get tan y as 1 by 2. Therefore, cos inverse of 2 by root 5 can be written as tan inverse of 1 by 2. So simplify, substitute these two, that, and then you simplify. So if I substitute LHS becomes as tan inverse of 4 by 3 plus tan inverse of 1 by 2. Now x into y, 4 by 3 into 1 by 2. 4 by 3 into 1 by 2, but 2 ones are 2, 2s are, I am getting 2 by 3 which is less than 1. For x by less than 1 we have to go with the first formula, which is nothing but tan inverse of x plus y, 4 by 3 plus 1 by 2 by 1 minus 4 by 3 into 1 by 2. So what is the LCM? They said this is equal to 4 inverse, right? Tan inverse 2 3s are 6, so 2 4s are 8 plus 3 by the LCM is 6. I took 6 minus 4, 6 and 6 gets cancelled. So what I am getting answer? Tan inverse of 8 plus 3. Tan inverse of 8 plus 3, 11 by 6 minus 4, 2. See, tan inverse x, but I want to answer in terms of cot inverse. Tan inverse x can be written as 1 by cot inverse of 1 by x. Tan inverse x can be written as cot inverse of 1 by x. Otherwise, take the cot inverse x where x is greater than 0. This can be written as tan inverse of 1 by 2 by 11, which is equal to. So I am taking RHS also. I am taking RHS given as cot inverse 2 by 11. If I consider this as x is greater than 0. If x is greater than 0, cot inverse of x can be written as tan inverse of 1 by x. So what I get? Tan inverse of 1 by 2 by 11 can be written as 11 by 2. Therefore, LHS equal to RHS. Sine of 2 tan inverse 2 by 3 plus cos tan inverse root 3. So first we have to evaluate this one separately and this one separately, then you add, you will get the answer. So if I simplify this one, sine of sine inverse x or sine inverse of sine x will give the answer x. So the entire thing we should able to convert in the form of sine inverse. Then it can be simplified. Next, cos of tan inverse x. So if I able to convert this particular tan inverse x in terms of cos, this tan inverse x in terms of cos, so we can write it as x, can be simplified. Let me solve this. If it is 2 tan inverse x, 2 tan inverse x can be written as 2 tan inverse x can be written as sine inverse of 2x by 1 plus x square. 2x by 1 plus x square. In the same way, tan inverse x in terms of cos can be written as cos inverse of cos inverse of 1 by root 1 plus x square. 1 by root 1 plus x square. Now, if I substitute these two formulas in this, we'll get the answer. So, the given thing can be rewritten as sine inverse of 2 tan inverse x can be written as sine inverse of 2x by 1 plus x square. I am rewriting it sine inverse, is a sine of, I am rewriting this as sine inverse 2, in place of x we have a 2 by 3 by 1 plus x square, which is nothing but 2 by 3 whole square, plus cos tan inverse of x can be written as cos inverse 1 by root 1 plus x square. So cos inverse 1 by root 1 plus x root 3 whole square. So simplify this one. Sine inverse 4 by 3 by 2 square 4, 3 square 9. So I write it as 1 plus 4 by 9 plus cos inverse 1 by root 1 plus root 3 square is 3. Next, sine inverse 4 by 3 by 9 plus 4 13 by 9 plus cos inverse 1 by 2. Cos inverse 1 by 2. So cos inverse x is x. Sine inverse x is x. So which is 4 by 3 by 13 by 9 can be written as 4 by 3 into 9 by 13. So 3 1s are 3 3s are. So if I take LCM, 13 2s are 26. 13 2s. So 2 4s are 8. 8 3s are 24 plus 2 how many times? 13 times plus 13, which is equal to 24 plus 13, 37 by 26. So the value of this entire thing is equal to 37 by 26. Next question. Cos inverse of cos inverse x is equal to pi by 6. Solve. Okay. So this cos inverse, if I transpose right side, what it happens? Sine of cos inverse x equal to cos pi by 6. We have sine of cos inverse x or cos of sine inverse x as root of 1 minus x square, which is equal to cos pi by 6 root 3 by 2. Squaring on both sides, what I get? 1 minus x square equal to root 3 square, 3 by 4. Now 4 minus 4x square equal to 3. So 4 minus 3 equal to 4x square. 4 minus 3 is 1. 1 is equal to 4x square. X square equal to 1 by 4. X is equal to root of 1 by 4, which is equal to plus or minus 1 by 2. So I have to check plus 1 by 2 minus 1 by 2 existed or not. Plus 1 by 2 and minus 1 by 2, which are lies in between minus 1 comma 1. See, plus 1 by 2 and minus 1 by 2. Plus or minus 1 by 2 belongs to minus 1 comma 1. So both are our answers. Tan inverse of x minus 2 by x minus 3 plus tan inverse of x plus 2 by x plus 3 equal to pi by 4. So solve. Whenever they say solve, we have to find x value. So we simplify this one and we find out x value. See, tan inverse of x minus 2 by x minus 3 plus tan inverse of x plus 2 by x plus 3 equal to pi by 4. So which is in the form of tan inverse x plus tan inverse y, which is equal to pi by 4. Tan inverse x plus tan inverse y can be written as tan inverse of x plus y. So we write it as x minus 2 by x minus 3 plus x plus 2 by x plus 3 by 1 minus xy x minus 2 by x minus 3 into x plus 2 by x plus 3, which is equal to pi by 4. Next, tan inverse, so can be written as tan pi by 4, transfer to right side, we get it as tan pi by 4. Simplify this, the LCM is x minus 3 into x plus 3, x minus 3 into x plus 3. Numerator x minus 2 into x plus 3 plus x plus 2 into x minus 3 by 1 minus. So what will be the LCM for this? LCM x minus 3 into x plus 3, LCM x minus 3 into x plus 3. So we have 1 by 1, so we get here x minus 3 into x plus 3 minus x minus 2 into x plus 2. Denominators gets cancelled. Numerator multiply x minus 2 into x plus 3, x square plus 3x minus 2x minus 6 plus x square minus 3x plus 2x minus 6 by a minus b into a plus b, a square minus b square, x square minus 9 minus of x square minus 4, which is equal to tan pi by 4, which is 1. Next, plus 3x minus 3x gets cancelled, minus 2x plus 2x gets cancelled, x square plus x square, 2x square, minus 6 minus 12 by x square minus 9 minus x square plus 4, which is equal to 1, minus x square plus x square cancel, 2x square minus 12 equal to minus 9 plus 4 minus 5, minus 5 into 1 minus 5, 2x square equal to minus 5 plus 12, 2x square equal to 12 minus 5 7, 12 minus 5 7, x is equal to root over 7 by 2 plus or minus. Tan inverse x by root of 1 minus x square. So these are not in terms of sin, cos, tan. So we have a tan inverse in terms of something. Directly we cannot simplify, but we can simplify using substitution method. Use substitution method. Let x is equal to tan theta. Substitute x is equal to substitute x is equal to sin theta. So why I am substituting sin theta? Why I am not taking tan theta? I'll explain here. Under root 1 minus x square. If I substitute tan theta, 1 minus tan square theta, so it's not useful. 1 minus sin square theta, useful. 1 minus cos square theta useful because 1 minus sin square theta can be written as cos square theta. Square and root will be gets cancelled. That's why I am using either sin theta or cos theta. So I took sin theta. Substitute sin theta. Tan inverse of sin theta by root of 1 minus sin square theta equal to tan inverse of sin theta by root of 1 minus sin square theta cos square theta. Square and root gets cancelled. Tan inverse of sin by cos tan theta. So my answer is tan inverse of tan theta is theta. Now I have to replace this theta. Theta is equal to, from this what I can write? Theta is equal to sin inverse x. So what is my answer? Sin inverse x. Next. Solve 4 sin inverse x plus cos inverse x equal to 5. So 4 sin inverse x can be written as 3 sin inverse x plus sin inverse x plus cos inverse x equal to 5. Sin inverse x plus cos inverse x is equal to pi by 2. So I am using that statement. So I write as 3 sin inverse x plus pi by 2 equal to pi. So 3 sin inverse x equal to pi minus pi by 2. 3 sin inverse x equal to 2 pi minus pi. So pi by 2. Sin inverse x equal to pi by 3 multiplying times 4 divides 2 3s are 6. So x is equal to sin pi by 6. Sin pi by 6 1 by 2. The value of x is 1 by 2 pi by 10. For some value x belongs to R, find cot inverse x. So we are going to find this cot inverse x. We have a relation between tan inverse x and cot inverse x. I use that relation. Tan inverse x plus cot inverse x equal to pi by 2. So I have a tan inverse x as pi by 10. So pi by 10 plus cot inverse x equal to pi by 2. So cot inverse x equal to pi by 2 minus pi by 10. Take LCM. 10 to 5 times, how many times? 5 times 5 pi minus pi, 5 pi minus pi, 4 pi by 10, 2 is 5. Cot inverse of x is equal to 2 pi by 5. So there are many problems like this. So keep on doing the problems by giving the conditions in your mind. Solve, you definitely get the answers. And solve all the example problems to get more understanding. Right? With this we are going to complete inverse trigonometric functions.